Good morning and most welcome to the Medical Science Study Center of Gothenburg, close to the famous Linnéplatsen and the lovely botanical garden where we are awaiting Hanami coming up soon. I will today speak about a fractal epistemology for a scientific psychology by MARKS-TARLOW. And let me start out with a quote from one of the most famous quantum physicists, John Archibald Wheeler. No one will be considered scientifically literate tomorrow who's not familiar with fractals. That indeed is the case. Fractals are foundational for reality, not atoms, molecules. And for understanding what it's all about, whether it's psychology, physics, sociology, you need fractals and fractal knowledge. The old model of viewing things in black and white, it's a thing of the past. Now we have dimensions between true and false, outside and inside. There are all varieties that were not allowed in the old system. I will start with the first chapter in the book by MARKS-TARLOW herself. And we had earlier on, maybe 500 or 600 lectures ago, fractals by Gleek and also David F. Peat, Briggs. So that it's been a returning subject. Going all the way back to the 100th series, I would think, where Arkady Plotnitsky mentioned it in connection with a segue into quantum mechanics. There will also be a link for you to go to her homepage and have a look-see at the PDFs. She's very generous and uploaded all of them, although it seems the numbers are not corresponding exactly. Yeah, the page numbers, thanks. But this in the book is page 2, chapter 1. A fractal epistemology for transpersonal psychology by MARKS-TARLOW. Since the inception of transpersonal psychology in the late 1960s, controversy has surrounded the scope and definition of the field. One early aim of this incipient discipline was to transcend limitations of research and methods available for conventional psychologists. born within the humanistic movement. Maslow's 1971 book title expresses his desire to explore the farther reaches of human nature. Much of his early work involved documenting peak experiences, altered states of consciousness, and spiritual dimensions of life. This was in line with the field's early goal to reject a narrow focus on psychopathology and bring into scope the whole person. From the beginning, highly subjective phenomena of interest to transpersonal psychologists possessed the characteristics of being ineffable and ambiguous. They often involved rare and unreproducible states of mind, fringe rather than normative experiences, and aspects of awareness that are highly personal and culturally specific. Beyond difficulties in quantifying such mental states, an identity confusion has pervaded the subfield of transpersonal psychology within academic psychology at large. Are these social or soft sciences primarily qualitative, descriptive endeavors akin to the humanities? Or are they quantitative empirical undertakings, more like chemistry, and other hard sciences. Theorists such as Walsh suggested an inclusive, integrative strategy whereby all approaches to transpersonal phenomena are recognized as valuable. Likewise, Wilber, 1983, argued for an expanded epistemology that includes sensory, mental, phenomenological, and contemplative data. To these folks, any single approach, no matter how objective seeming, is nonetheless only partial, limited, and unable to capture the whole truth. On the other side of the transpersonal divide, Friedman argued for greater scientific rigor. From his point of view, theories of everything, such as that of Wilber, which arise out of a fully inclusive attitude, water everything down so fully as to explain nothing. Friedman proposed that the designation of transpersonal psychology be reserved for only that which can be empirically studied. While purely subjective phenomena and fringe disciplines, like astrology, be gathered under the looser designation of transpersonal studies. As debate rages on, George Ferrer counter-argued that Friedman's supposedly objective lens of strict empiricism is guilty of its own charge. since no perfectly objective stance exists. Every perspective is fraught with its own set of assumptions and biases. I will go down to the last paragraph here on page 3. Yet, despite this reputation for rigor, Lakoff and Nunez 2000 asserted that even math has no objective origins. In their book Where Mathematics Comes From, these researchers argued that mathematics is instead a fully embodied discipline, emerging from, and this is important, the movement of our bodies as they interact in the physical world. Lakoff and Nunez pointed out metaphorical origins for even as basic a concept as number. Which can be conceived in multiple ways. Depends upon which metaphor is chosen. Whether considered a collection of objects, a member of a set, or a point on a line. This has important implications. Including entailments that lead not only to wholly different branches of mathematics, but also at times to contradictory assumptions among these various branches. And I think the important thing is that there is a movement. We now know that without movement there can be no stasis, there can be no objective truth, neither subjective. So it's the bodies moving, not bodies in a fixated position. Since his invention of fractal geometry during the 1970s, Benoit Mandelbrot considered this new branch to be the mathematics best suited to understand features of the natural world. In fact, in the Fractal Geometry of Nature, his manifesto published in 1977, Mandelbrot offered fractals as a framework for modeling aspects of nature previously considered too ambiguous, irregular, unique, discontinuous, or complicated for traditional mathematical methods. Over the past 50 years, tens of thousands of researchers have used fractal geometry to model every facet of nature, from microscopic patterning within the quantum realm to the cosmic patterning of galaxy clusters, as well as everything in between at the mesoscopic level. My comment here, we have also seen that thinking is fractal. It is not zeros and ones. It is dependent on the dialectical movement. Jacques Derrida was one of those philosophers that went into a text and showed it to be stillborn, dead, when it depended on monosemic and polarities too much, not bringing any fractality. So you see Frobel that we brought up some 500 lectures ago. She's spelled with a V, Frobel. Definitely recommendable. She also went into the area of showing time and understanding to be of fractal nature. By assigning quantitative number to qualitative aspects, fractal geometry is ideal for understanding natural features like the fluffiness of clouds, the jaggedness of a shoreline, or the ruggedness of a mountain range. This mathematical power to model complicated patterns extends from outside to inside the human body. Pioneer nonlinear researchers such as West and Leibovitch documented how fractal patterns pervade the complicated physiology of our lungs, circulatory system, and neural structures. Other examples of its utility include fractal measurement to differentiate tumor from normal cells, as well as differences in the visual production of famous artists who suffered from degenerative brain conditions versus those who did not. Oh, sounds incredibly interesting. In my own work as a clinical psychologist, I have written extensively about the fractal geometry of human nature. I believe that nonlinear science broadly and fractal geometry specifically provide a holistic, flexible meta-framework for understanding even the most complex psychological, social, cultural, and historical systems. Because fractal patterns extend across space, time, as well as symbolic realms. Fractals can illuminate complex interrelationships. Such as the interpenetration between brain and mind, self and other, and the inner versus outer realms. In sections to follow, I begin with a brief description of the history of fractal geometry, including its uncanny parallels with the early history of transpersonal psychology. So here is a retake by Terry MARKS-TARLOW. What is a fractal? Everywhere we look, fractals surround us. In the branching patterns of a tree, the spots of a leopard, or the wrinkles of an elderly human face. Although each of us understands fractal patterns intuitively, in an embodied way, very few of us tend to see them consciously. Why is this? An important reason may be because the field of fractal geometry is too new. Few of us have grown up with fractal objects as part of our visual or mathematical lexicon. Instead, traditional Western education has privileged linear lenses by highlighting straight lines and regular forms, such as Platonic solids and Euclidean dimensions. A comment there. Me, myself, I believe that the Euclidean dimensions were the only ones existing until I was 16. Goes to show how encompassing this thinking is. It is easy to remember elementary school activities of playing with such shapes, for example, cutting out and pasting a larger triangle onto a smaller rectangular base and calling it a pine tree. Yet all the while, we could sense our productions as mere approximations of the real thing. What constitutes the real thing? In other words, how do natural shapes differ from human-made ones? Is there an archetypal meta-pattern? That is, a pattern of patterns that nature draws up again and again. The answer appears to be Yes. Nature loves recursively enfolded shapes, which is patterns that are repeated over and over on multiple size and or time scales. When in elementary school, we could have just as easily played with fractals. Had we cut out multiple triangles, each the same shape, but slightly different in size, placing the smallest on top of a layered series, all laid up upon the smaller rectangular base. We would have played with self-similar fractal objects while producing a more realistic pine tree. It is ironic that so few of us have developed a conscious awareness of fractals, despite our implicit awareness of them, given what may be a fractal stage of most children's art, akin to Gardner's tadpole figure to represent the human figure. Figure 1-1 represents an example of fractal art spontaneously created by my then 5-year-old daughter, whether the shape consists of a heart, diamond or oval. There appears to exist a universal desire in children to play with the same shape on different size scales. Meanwhile, just about every parent recognizes some variation of this drawing within their own children's early art production. An important reason that fractals may play a stage in children's art involves the dynamics of the visual field. As people approach or retreat from babies similar shapes on different size scales appear and reappear successively upon the flat surface of our retinas. Objects or people appear larger as they move towards us, or we move towards them. And smaller as they or we move away. In this respect, our eyes intuitively understand the multi-scale quality of fractal dynamics. Which works as an algorithm to make sense of our own position relative to people and things in our visual landscape. This hallmark property of a fractal, as stated more formally, is called self-similarity. Within fractal geometry, self-similarity means that the large-scale pattern of the whole gets repeated on multiple size or time scales within its parts. And very important here, it's both spatial and temporal. It could be different time scales, something developing maybe instead of 1 second, 10 seconds or a year. Iteration goes in time as well. Self-similarity involves recursive, that is, self-reflexive symmetry. A related fractal property is called scale invariance. Which means that the same pattern repeats itself either identically or approximately across multiple size or time scales. Many growth processes are self-similar as well as scale invariant. Consider the successive growth of a Nautilus shell, as illustrated in figure 1.2. The mathematical qualities of the algorithmic spiral reveal how the shell's basic shape or identity gets maintained by preserving part/whole relations despite successive changes in size. This is incredibly important. Let me just repeat it. I will draw it also. The mathematical qualities of the algorithmic spiral reveal how the shell's basic shape or identity gets maintained by preserving part-whole relations despite successive changes in size. We mentioned that iconoclastic individuality in last lecture 1423, but in the context of quantum mechanics. So you see the connections here. The numbers inside the boxes 1, 1, 2, 3, 5, 8 are named the Fibonacci sequence, first defined by Euclid and written in the 15th century by Luca Pacioli, an Italian monk reputedly drunk on beauty. To get the next number in the series, simply add together the previous two numbers. By dividing each pair of successive numbers, one arrives even closer to the golden ratio. For millennia, the golden ratio number has been capitalized upon in art, architecture, romanticized in literature, and spiritualized under the name of sacred geometry. Because of the self-similar preservation of, and listen now, part-whole relations. This is what individuality is. The Fibonacci series represents an early recognition of this special quality of fractals that describes many common aspects of nature. From the reproductive rate of rabbits, to the spirals of a sunflower, to the helical form of a pine cone. Beyond the Fibonacci series, there exist multiple ways to construct a fractal. One involves applying the same algorithm or procedure over and over again to a seed shape. Consider the Koch snowflake. in figure 1.3. The seed shape consists of a triangle. The algorithm involves removing the middle third of each side, replacing it with 2/3 of a smaller triangle. The figure below reveals the first 3 stages or iterations of this process, which can extend indefinitely, at least in theory, even though at a certain point our eyes fail to see the tiniest iterations. And the Koch snowflake is absolutely gorgeous. It's really beautiful. I will make a little summary here, if my colleague could please put a pause. Welcome back, and I will try to make a little summary of the basics of fractality that Terry MARKS-TARLOW have expounded clearly in her first introducing chapter. And one clear fractality is the so-called Fibonacci series, where individuality is kept in the scaling up and scaling down, either time-wise or temporally. This is the most important feature. The golden ratio can be found in great orators like Winston Churchill, Woodrow Wilson, Roosevelt. Speeches that are convincing and carry meaning. And also a very important feature of the golden ratio, successful argumentation in writing is always high on the level of golden ratio. Writings you find within science, enterprise, politics, all carry a high level of fractal complexity of the golden ratio. It means that these writings are successful, they carry meaning, and they make a difference. They are perceived as being good. And oddly enough, the same goes for paintings. These are things that we in common sense think are unrelated, not connected. But they are indeed. We know within education the golden ratio has gone down. It is the truth value of texts are lower. They do not correspond. They do not carry meaning. Using the old format is of the kind saying they don't represent anything in reality. I would rather say they are not part of reality. They are repetitions rather than iterations. They do not preserve identity. This is a contrast I usually like to make. Repetition versus iteration. Iteration preserves identity, preserves meaning, preserves identity, if you like. 1 to the 2 to the 4 to the 8 to the 16, going onwards, whereas repetition, the modern monosemic take on meaning that doesn't affect, as we know as a fact, is repetitive and not permanent, lacks the individuality. It doesn't have something you can recognize as something. My old professor in phonetics, Per Ling, he used to say that it is just a blur. It's a non-understandable blur that doesn't carry meaning, or at least very little. That is the problem with repetition, which has become standard. The golden ratio, on the other side, is deeply fractal. It's complex. It has the potentiality to carry meaning, and it can preserve it. Preservation of identity and meaning is what we mean by scale invariance. In normal, so to speak, non-oppositional text, there is no preservation of meaning. It can easily be seen when spoken. It doesn't carry any meaning. It is like a fog on the oscilloscope. All shapes of nature and human-made is dependent on its fractality. There are no exceptions. When we like to go into fractality, we use obvious examples like a fern or a cauliflower. But it's important that every aspect of reality is sharing these characteristics of the fractals. And as Terry MARKS-TARLOW said, it's no matter if it's galaxies, the lowest microbes, atoms, quantum effects, and also the intermediate level where we human beings subsides. Our bodies are built up of fractality. The old system that we are a bony architectural structure that carries flesh is long gone. What carries us are the fascia. It'd be good to know fascia was unknown until quite recently, at least that it is building up the body. And they are deeply fractal. They are also tensegral, very strong, although to the human eye, when you look at them, they look very fragile and thin. This is strength. This is a strong argument. This is the speech of a successful person. This is the writing of a book, an argument, an article that sells, that has impact. Supposed to be compared to the standard linear way where the text loses its impact. It becomes grotesque, lacking the beauty of the golden ratio, not working, being untrue in a real sense, not untrue in the binary sense of true versus untrue on a scale. That scale invariance is very important. Sticking to one part of the scale ladder means that understanding cannot come to the fore. It means that there is a stoppage and nothing is transferred. This is the strength of the Fibonacci series and the golden ratio. They need to be followed if strength is to be achieved in whatever aspect. And it doesn't consider the, so to speak, normal outlines or borders that we call intellectual, mental, psychological, or material, reductionist, atomistic. Fractality goes over all areas. And they are unique. They can carry meaning over millennia. There is an example, a tribe in southern India who preserved the original first language without clear words, a sort of singing. That knowledge has been transferred for at least 3 millennia, if not even more. That's the power of fractality and scale invariance. It's a powerful tool and it's up for grabs. You can use it if you want to be successful in what you do, or you can ignore this incredible natural way of doing things, the golden ratio. Maybe there's some questions?
Today I have only ignorant questions. So Hans, I would like that you soon as explain this. I'm not a mathematician, so why did you do that? And then more concretely, how does the observer come into the fractality? We have seen in another paper by MARKS-TARLOW fractal geometry. That is, if you measure the line of a coast, then you enter into fractality. But the golden ratio, how does it enter with the observer?
Very good questions. This is the spiral that comes up once you duplicate. For every time you duplicate, the spiral becomes wider and broader. That's the direction of a text. Susie Froebel described this as the foundations of thinking. It's not really mathematically, not more academic, like the kernel of what academia is. What is it to be an academic? It's to understand this. It brings meaning. And great texts, and this is also a point from Derrida, great texts have this trait. they tell. And the spiral is instead of the idea of this dichotomy between truth and false that sort of splinters the text, make it less valid. The second question is an even better one. How does the observer come into the format? Well, it is the spiral that is the observer. The spiral reads off and is what reads at the same time. And this is a co-joint venture. So object and subject are simultaneously reading themselves out. There can only be a readout when both the object and the subject are participatory in a complementary fashion. I will jump a little bit ahead in the book, but at other articles, Terry MARKS-TARLOW has shown it like this, that the complexity of, let's say, the Norwegian coastline is so complex, so jagged, so complicated, that it reads off the sea. There is a movement here. That movement is the spiral. Stillness and movement are codependent, and without movement there can be no stasis. Without stasis there can be no movement. We know from this that the only thing that can understand is a complex fractality. Nothing else. Zeros and ones simply won't do. We need fractality. And as you asked, where is the subject? Well, the subject is the movement. It's a movement like in Pfeiffer's moving robots that understands. So see the spiral as a moving thing, that the text or the argument, the speech, is moving. It's moving thanks to there be a following of what makes up fractality. I can just mention here in bypass when we speak about fractality and the shoreline of Norway. It is actually the longest, second longest shoreline in the world. All other countries are beaten by Norway. I think that is astonishing in itself. Did that sort of answer your question, Kalle?
Yes.
Do you have some follow-up?
Let me understand. For Ian McKellickris, the ideal geometric form is the spiral, or was it the vortex? I think it was a spiral.
It's almost the same.
Yes, a spiral vortex. Really, almost more the same. So, how does the spiral relate to the Color ratio? Are they the same, geometrically speaking, or so this is what is this the Color ratio then, geometrically speaking? So you could say this Color ratio looks like a spiral, and I have been working on the So how do you get this spiral thinking in everyday reasoning? And it struck me that if you make the vortex or spiral, you do it like this more or less. Can you check? And then visually, if you take out a part of it, you have the parenthesis. So that is more a healthier approach to nature. It's difficult to reproduce this, let's say, in a Word document if you're working, but what you can do is you can reproduce parentheses. Why is parentheses important? Because they are closer, they are fluid, they are movement, and therefore I recommend, let's say, this parenthesis instead of, let's say, square brackets in a text. And I'm working on arguing for a new type of edition of the Greek New Testament instead of using this. They create dichotomies, but these are more fluid, a healthy way of. So spiral could be a good way to arrive a healthier text. Although I'm not saying that parentheses are the same as spiral, but they are in the some kind of fluid thinking. That's my point. I give you back this to you.
I can also in this context add another thing that could be helpful for some and compare it with something we mentioned before, and that is that only staticness of the syllogism, an area I stem from originally, logic, doesn't have this scaling variance. It is lines, two propositions, making a conclusion. The linearity is not scaling variant. It is sort of fixed, and therefore it doesn't have the movement, so it cannot be static either, and it cannot be telling. It doesn't bring anything. It doesn't have the healthy fractality complexity. This can help to see what we have presently, that fixatedness going from the top to the down. It's also a left to right action here, where each line is disjunct, not healthy wholeness. There are no holes here. To borrow a phrase from Stephen M. Rosen, it's solid, it's stone logic, as Edward de Bono would have it, definitely stone logic. In his marvelous book, Little Booklet, Water Logic, used the anaphor of bricks, that ordinary thinking is brick-like, adding things on top of each other. Obviously, it's very close to that horizontal, putting things on top of each other, although the direction is down. This is more his water logic. Scaling variance is very important to have consistency in a text and to have unification in a text as well. Speaking of text, maybe I should continue a bit with directly of Terence Terry. See where I left off. Do I look fairly okay?
Yes.
Checking out the lighting here. So we left off at the Koch snowflake, which I highly recommend that you go into. They're very interesting. Fractals like the Koch snowflake are linear because the identical pattern is repeated on each scale. Fractals can also be non-linear by tossing a bit of chance or randomness into each iteration. Herein lies a critical difference between the regularity of human-made objects and the irregularity of natural ones. Consider, for example, the genetic code. Despite a single underlying growth algorithm, intensely variable conditions within the environment tweak the resulting epigenetic manifestations. From ever so slightly to quite dramatically. Figure 1 to 4 helps to visualize the difference between the linear fractals and non-linear ones. History of fractal geometry. Within the history of mathematics, linear objects and additive methods have prevailed. Consider the invention of calculus in the late 17th century, simultaneously by Newton and Leibniz, designed to capture continuously evolving dynamics of motion. By chopping the space under a curve into smaller and smaller units, each subsection could be added together to reveal the total area. Using the device of calculus, very complex curves could be broken down and measured. The concept of infinity creeps into the methodology as follows. It lurks implicitly as an idealized point at the limit of the measurement as the size of units become infinitesimally small and shrinking towards zero. My comment here is this is the production of the point. The concept of infinity plays a more explicit role in the invention of fractal geometry. Consider the mathematician George Cantor in the late 19th century. Whose work was an important precursor to fractal geometry. Up until Cantor's time, it was assumed that infinity was absolute. That it is that infinity comes in one and only one size. This idealized and definite view was why some mathematicians equated mathematical productions with the hand of God, whose infinite power was conceived as equally absolute. By innovating a method of one-to-one correspondences, Cantor discovered that there are endless flavors or sizes of infinity. Such as the difference between the set of rational numbers versus the set of irrational numbers. Even bigger is the size of the set of all sets of numbers. By introducing an infinity of infinities, Cantor gave birth to a new field called transfinite mathematics. At the inception of transfinite math, many mathematicians were shocked. Poincaré referred to Cantor's ideas as a grave disease that was infecting the field of mathematics. Whereas Cantor believed his discoveries had been handed down to him by God, some Christian theologians feared Cantor's work challenged the uniqueness of God's absolute infinity. One way to understand Cantor's brand of infinity is to contemplate his fractal contribution called Cantor dust. Whereas the Koch snowflake uses each successive iteration to add structure, Cantor dust uses each successive iteration to remove structure. In this case, the middle third of each line. Another 19th century iconoclast and precursor to fractal geometry was Giuseppe Piano, whose space-filling curve, much like both the Koch snowflake and Cantor dust, is notable because it eludes conventional methods of calculus. Because the Piano curve possesses no tangents, it is considered undifferentiable or outside the scope of calculus. Mathematical forms produced by Koch, Cantor and Peano represented new and unconventional objects that were met with high suspicion. At times, mathematical colleagues dismissed these objects as irrelevant. At other times, they rejected them as outliers or deemed them pathological and a gallery of monsters. Looking back at the revolution of ideas that separated the classical mathematics of the 19th century from the modern mathematics of the 20th century, it is ironic that the very shapes dismissed as irrelevant and rejected as monstrous have proven over time to conform most highly to nature's recursive patterning. Within the history of transpersonal psychology, Stanislav Grof documented the prediction of mainstream psychologists and psychiatrists to similarly reject and psychopathologize transpersonal phenomena of interest. As a trend, Western materialistic scientists easily dismissed the realm of spirituality as reflections of mere ignorance, gullibility, superstition and self-deception, or primitive magical thinking. Meanwhile, the experiences of visionaries, prophets, or saints at the root of world's major religions are frequently seen to be indicative of serious mental illnesses. In the words of Grof, Saint Anthony has been called schizophrenic. Saint John of the Cross labeled a hereditary degenerate. Saint Teresa of Avila has been dismissed as a severe hysterical psychotic, and Muhammad's mystical experiences have been attributed to epilepsy. Franz Alexander, known as one of the founders of psychosomatic medicine, wrote a paper in which even Buddhist meditation is described in psychopathological terms and referred to as artificial catatonia. Perhaps these parallels between the early days of fractal geometry and those of transpersonal psychology are less coincidental than they might seem. While mainstream mathematics was busy addressing conventional issues, Cantor, Peano, Koch were examining fringe ideas. In parallel fashion, while mainstream psychology was following its own set of normative trends, transpersonal psychologists were also drawn towards the fringes. Grove asserted ontological realism for transpersonal experiences of the interconnection between all beings and levels of existence, an idea dismissed primarily by reductionist scientists.
One hour 39.
Cheers. Perhaps pioneers in fractal geometry and transpersonal psychology were rejected as unconventional, even heretical, largely from the perspective of reductionist science. Perhaps two fields share a similar history because through more holistic integrative lenses they both model the same thing. What is unique, irregular, and rare in nature, including human subjective experience. There is a famous paper by the mathematician Wegener entitled "The Unreasonable Effectiveness of Mathematics in Natural Sciences." I would say that was a very important book when we looked into Lee Smolin earlier on. It is very compelling has its problem as well. Wigner's focus was primarily on amazing correspondences between mathematical formulae and outer physical realms of the material level. Perhaps we are on the cusp of transformation by perceiving the unreasonable effectiveness of mathematics within the social sciences. In the spirit of Wigner, I suggest transpersonal psychology needs a more holistic scientific mathematical fractal framework to embrace the full breadth and depth of its psychological and experiential scope. And we're just coming into the really interesting things here. We'll go into that into the next lecture and also give a practical demonstration of spirals in our bodies. This was investigated by the South African anthropologist and anatomist Raymond Dart, whose famous procedure, the Dart procedure, is something we've been using for quite a while under the guise of constructive rest. Since fractality came out into the open after especially Lawrence, but it really happened with the IBM engineer Benoit Mandelbrot, spirals have been found everywhere. It was also mentioned when we took up Stephen M. Rosen. He spoke about spinors and movement inside of the Möbius strip. That together with the lemniscate can be shown to be moving in staticness. Movement is not an add-on. Movement is within staticness and matter. It is what makes matter be able to spring into presencing, which is movement and stillness simultaneously. All these different aspects of understanding have been made possible by the discovery of fractality. I think Terry, MARKS-TARLOW have started a very wondrous cooperation or crossover between transpersonal psychology and fractality. I also think it would be a good idea, an interesting idea, to have her interviewed or have some points of her books taken up and discussed. Usually we think that movement and stasis are disjunct and have no resemblance to each other. You can think about the coordinate system I mentioned so many times before, where the different directions in space, orthogonally perpendicular, related to each other, have an add-on, an additive time. And this time dimension is something constructed from the other dimensions. And we spoke with Stephen Ambrose, and this is maybe the first step, but this is not how depth comes into the picture. Depth is actually time together, like this jagged fractal, knowledge-laden infinity. And for each magnification, you will find new things erupting. Stranger patterns, more decisive things. That iteration on the scale makes for a very strong structure, and it makes for the movement. Without movement, you will not have the object. Goes for the text, goes for speech, as I mentioned early on. The most famous and successful speakers are fractal in their voices. They obey the golden ratio, which means that their words carry meaning. They carry force. Not in the idea of forceful speech, but it carries actual meaning, saying something to people. I especially like the speech that Winston Churchill had in the Parliament, and the decision was taken to defend England from the battle that Germany forced upon them. And they succeeded. A lot thanks to a fractal-laden speech that showed the character of his decision to not surrender. Maybe there's a question or two from my dear colleague, Kalle. You want to add something?
No, perhaps you should do the experiment, because we don't. 1 hour and 50 already.
Ah, well, that had to. It's for the next lecture.
Ah, okay. No.
Well, I will later show how spirality erupts in bodies. That will take some introduction into the spirals of the body. But they are within the pulmonary system, the cardiac system. That's also what keeps us upright. It's the force that makes us having a direction from the very start on. It is, well, it's a force of the universe itself. And what it makes when it moves is fractality. So you can also see the fractality as the trace of the movement. As you see here, this is the leftovers of the movement as well. So see the movement you have in the Norwegian coastline as an actual movement. Something that is literally happening. And then you will go closer to an understanding of what depth is. Something that we earlier discussed with Merleau-Ponty. We went into the subject of the one dimension that starts everything, the one dimension that, so to say, underlie what constitutes reality. This is constitutive of what reality is. And it goes very close to what we speak about whole. There is solidness in the old model. I mentioned earlier the syllogism, but do remember Parmenides, who said everything was absolute solidity. No holes in the term H-O-L-E. No holes in the manner of holes in this way, and therefore there can be no whole, as in wholeness. You need the whole to have wholeness. You need a whole in the text to have a whole text, a telling text, a spirally directed text. Such a text will be imminent in the reader as a direction going somewhere. And that's why I brought up the speech, this famous speech by Winston Churchill. It set a direction. It set a direction for the whole nation. And we know that for a fact, but we haven't known the reasons. And often, too often I would say, the speech of Winston Churchill has been analyzed in the idea of what takes away wholeness, the syllogism. That's a reduction of a strength, of a directionality. I think my colleague still has a question here.
No, only a little bit banal observation. As I work with texts, and I would like to return to this neologism by Stephen Rosen. And you have it in visually, so to say, you could say that this O represents the whole, the whole. Because how do you visually represent the whole? That is this whole. The whole is like that. Let's say I have a hole here somewhere, so it's a visually this O here. Do you understand what I mean? So it's visually you have it in the letters themselves, and then you have this W. It's like a spiral form, or like a snake. And so you have it. This is the vortex, so say, roughly speaking. Or movement. Let's say we have the movement here, movement, and movement, and then you have here the whole, and so you need both the whole, something broken, you would say like that, and then you need also the movement. And so paradoxically speaking, to have the whole, you need a whole, something broken, and you have the hole in the spiral. Let's do this because this is fun, and fractal, this should be fun.
It is fun.
And so perhaps the mystery is in the small hole, which is also visually looks like an atom. Although we shouldn't think that they are real, like Carroili says, so electrons, that they are real. but you need this whole with a W to get the whole. So those who focus so much on cells that the cell is the main thing miss the point. They miss the whole with the W. That was the point. So you can do much with Rosen's neologism.
Yes, and I would also say that it is mostly ignored when you mention the O. For it to be an O, there needs to be absence. Otherwise, you will just have a dot. And it's filled out like in the Parmenidean take. It cannot carry meaning. And this is something that we usually ignore. And something that Jacques Derrida so many times pointed out, that we need a piece of paper. The blankness that constitutes is absence, is necessary, otherwise the text would be sheer blackness and wouldn't be able to tell anything. And that goes, I would say, for so many texts today. They are swelling over with blackness, allowing no dialecticity, allowing no energy to enter into the text. And this is why Jacques Derrida so many times healed the text. It made it whole by putting absence into the text once more. That is what makes for a good text. That also makes for meaning, to be able to tell something. I think it's about time for lunch and a little break before we continue.
Thank you.
There's some time left here.
Thank you.
I say thank you very much and have a very pleasant afternoon. Bye bye.